Hello, Godot community. I'm fairly new to Godot, and about a month ago, I was working on my first app that wasn't a tutorial, and I reached the point in the project where I needed some controls, and I found the control hierarchy and thought this is really cool. These relative controls are pretty neat. About a day later, I had some other choice words for it and decided I needed to take a little bit of time and explore how the control nodes work, the various containers, how they work together. And that same weekend, I found this cool project that a guy had written where he generates random sprites. So you click over here and it just generates random sprites. And you can click this button here and it turns on cellular automata, which generates some more interesting looking sprites. In fact, these particular sprites were perfect looking for another project that I was working on. You can add colors. That spinner is not working for some reason. And it makes them a little more complex, makes them more interesting. So I really like this little project, but it's closed source, and there were some other things I wanted to do with the actual sprite generation. So I thought, hey, this would make a good little side project to make an enhanced version of this tile generator and learn about control nodes at the same time. So let me introduce you to Tiley Generator. Stands for tile generator. Please don't give me grief about the name. So I decided to build a framework that I could just plug tile generators into, and then once the framework was done, I could just make tile generators and just plug them in. So let me show you the app, and then I will show you how to make a new tile generator. So here's the app itself, and when it first runs, it opens up with the random pixels tile generator, which literally just puts random pixels into the tile. And the controls here at the top right allow you to control the size of the grid over here and the number, and the size of the tile. So at the moment you can see the grid size is 4, so we're getting a 4x4 grid. Each tile is 128 by 128 pixels, and presently we're seeing the tiles at they're scaled up by a factor of 2. So if I scale them down to a factor of 1, we see them at their actual size, and I could then maybe I could put 8 of them in here instead. So the framework was pretty much coded with just this random tile generator. So I used this one tile generator to build the framework, and then I built the other generators. So let me just show you the other things you can do. And this random one is kind of interesting. It has some options down here that make it a little more interesting. For example, instead of just making one pass, you can make 2 passes, and so you'll end up with 2 different colors in here. You can change the distribution of the pattern by using a concept I call dice. So in other words, at the moment, all the random numbers are just being generated from 1 to 128, and that's how it's choosing a random pixel in both X and Y. But what if instead of just choosing one random number between 1 and 128, I chose 2 random numbers between 1 and 64 and added them together? So basically rolling 2 64-sided dice. Well, of course, that will do the same thing that rolling dice do, and that will tend to make the numbers more centralized. So if you change this here, you'll see that we get more central tendency for the pattern. And I'm going to go back to the defaults here. If you want to, you can turn on symmetry. So we can have it, I turned on symmetry in both directions. And so by default, it's drawing the whole image in one section and then just mirroring it. So I implemented this other option to draw the whole image and then take a slice of it and mirror that. And you get some kind of interesting patterns. But again, the random pixels one was just written mostly for the purpose of helping me design the actual framework that everything goes into. The automata that I was really interested in was the cellular automata. I'm sorry, the generator I was interested in was doing cell automata, but I had some other ideas. The first idea I came up with was just doing a fixed set of attractors, because this is a piece of code I wrote way back when I was a student, and it was a lot of fun to play with. So the idea here is you pick a number of points fixed in space, and generally you usually start with 3 points that are spread out on the edges, equally spread out on the edges of a triangle, or on the edges of a circle. And when you do that, you can end up with a fractal known as the Sierpinski triangle. And once you've got your fixed points, you choose any one point as your starting point, and then you pick any other point at random, and you move some fixed distance toward it. So maybe you move half the distance. So let's say I've got this point down here, and my other point is this one, so I move half the distance, and then I plot a point. And then I choose any one of the other fixed points, move half the distance, plot a point, and so on and so forth, and just keep that going. And intuitively, you would think that that would fill in the graph or fill in the space, but it doesn't. It generates these interesting fractal patterns, and I played with it a lot when I was a student, and so I just added that one in here. And so you can see you get some interesting patterns. And this one right here that's triangle, so that's 3 points, and it looks like the attraction value is probably a little less than, or maybe a little more than 0.5. But if it's exactly 0.5, you get the interesting Sierpinski triangle. Anyway, so that's the fixed set of attractors, and I've got a whole bunch of options here because things just kept popping into my head when I was implementing this, like, oh, what if I did this, or what if I did this? So in other words, for example, what if the attraction of every point wasn't fixed, but instead the attraction was actually random? Then you start to get some really funky patterns. All right. Cellular automata was also one that I decided to implement. And if you're not familiar with the idea here, so you generate a bunch of random pixels to start, and then you look at every pixel and you examine its neighbors, and you count how many neighbors it has that are turned on or off, or alive or dead in automata speak. And based on the number of neighbors that are either alive or dead, that pixel either stays on or off or turns on or off. And so you get these interesting patterns. And the rule that's generating these is very close to Conway's Game of Life. And in fact, if I change this to a 0, and this is now Conway's Game of Life, which generates these interesting patterns. Let me turn the symmetry off here, so no symmetry. So Conway's Game of Life, and it's doing anywhere from 1 to 8 generations of the automata, generates these interesting patterns. Conway's Game of Life tends to start building these clusters, and of course he chose his rules to match real life as much as he could. But you can also use random automata, which gives you all kinds of wild things. And we haven't talked about the color palette yet, but I'll talk about that in just a second. So the color palette over here is just available to the tile generator to use or ignore as it wishes. So I built it into every generator that I have, and the tile generator can decide what to do with it. So if I turn it on, at this point, it's just picking a random color from the palette and generating the tile from that. If I change the color mode to, for example, be generation intensity, then what it's doing is it's still picking a random color from the palette, but every subsequent generation, the pixel gets a little bit brighter. And I could go generation palette, and every subsequent generation uses a different color from the palette. So there are different things you can do with the color palettes, and I've got several actual palettes over here. I've got the default one, which is just some... I found a palette on the web that some guy said this is the optimum 16 color palette for converting images to 16 colors. I've got a simple palette that's just red, green, and blue with black and white. A few scaled ones, grayscale, red scale, and then a rainbow palette and a couple of terrain palettes, which the topographic palette is interesting in this next algorithm. So the diamond square algorithm is a fractal terrain generator, and it's not used a lot anymore, I don't think, because there are better terrain generators, but it's easy to code, and so I just included it. It has a tendency to introduce some artifacts that you can see. Let's change the palette to be a scale. And let me turn the smoothness up as well. I think if we do this, we'll be able to see the artifacts. Yeah, so you can see the artifacts that tend to occur on the major corners. The way that this algorithm works, it looks at the image as a whole and then picks a point in the middle, sets it to the average of those, and then looks at the smaller square, sets pixels to the average, and so on and so forth. So it tends to set pixels that are on those corners with more or less intensity, and so you get these artifacts. But if you turn the smoothness down so that you get more of a topographic look, you don't notice those artifacts nearly as much, and it's especially cool if you use a palette that's designed for looking like it's actual terrain. And you can get some really funky effects if you turn off the palette and just let it pick a random palette. You get some really weird looking stuff. Alright, and finally, I did a spirograph just because spirographs are kind of cool. And it's, if you haven't seen a spirograph, it's the toy where you have a plastic disc that has a big hole in the middle, and then you have a smaller plastic disc that you put a pen in and you just rotate it around, and it makes these interesting patterns. So I found a web page about the mathematics of this and just decided to implement it because you get kind of cool images. So the app itself is, you can see it's broken into a few regions. So over here on the left, this is where the actual tiles get put. Over on the very right is where I decided to put the palette. At the top are the controls that control the size of the grid and the size of the tiles. And then this area here in the middle where you see all the options for the tile generator, that's getting dynamically created based on the information in the tile generator itself. So let's take a look at that. So the app has so this area over here, this is where the sprites get drawn, and it's just one big panel called sprites, and so the app just generates them in there. And then I've got a place for the palette, I've got a place for my control here at the top, and then I've got a place for the tile generator. But the actual tile generators themselves are located underneath this gener node, and they are well, the easiest thing to show you is just let's make a new one. So if you want to make your own tile generator, we just come here, we add a new node of type node, and I had an idea for a tile generator that I thought would be kind of cool. If you pick a pixel at random somewhere in the middle of the tile and then move in any random direction, so pick a random direction, move one pixel, pick a random direction, move them, and just keep doing that until it wanders off of the edge of the tile. In theory, it might never get there, but with a true random generator, it should eventually go off the edge of the tile. So that would be called wandering pixels. And I've got a template here. So this template code, is this the template? Yeah. So the easiest thing to do is attach a script to this new node that we just added here, and I like to put them in a folder I call geners. So wandering pixels. So attach the script, and then I'm just going to replace this. I'm going to replace this default node script with the code from the template. So let's go over here, copy this, and the template is pretty simple. There's some code in here, and you can take a look at this. A lot of this is just comments, but the only thing that really you need to know about is this function right here called generate pixels. So you are given an image and you're given an array of colors, and all you have to do is just use this area to generate your pixels. So to convince ourselves that it's working, so there's a couple of properties that get exported. There's a name, gener name, and gener description. And so if you go back to the inspector, the name that you give it is what will show up in the option select that you see in the actual app. So we'll call it wandering pixels, and then this is the area where you put the description. And for now we'll just put the words wandering pixels description so that we can see that it's actually going in there. And this supports BB code, which gives you some options for making some nice descriptions. So if we run this, we will see that wandering pixels has been added to the list, but it doesn't generate anything because our code to generate pixels was not generating any pixels. My template actually implements symmetry by default. So if you want symmetry, sometimes it doesn't make sense to have symmetry, like in the spirographs. I may have left symmetry in the spirographs. Did I? No, I didn't. So it didn't make sense to have symmetry in this particular generator, so I took it out. But if you want it, it's there by default. You don't have to do anything. So to convince ourselves that this is working, let's just go here and let's just add 100 random pixels. 0, 2. This isn't the most effective way to do this, but it'll work for now. Did I do that right? Image. Now the width and the height of these images are the same, but I'm just going to use get width and get height just for the heck of it. So this will generate a random pixel somewhere across the width and height of the image, and I know that these values are going to be floating point numbers. So in other words, you're going to get pixels like 12.2 instead of just 12, but the set pixel will actually take care of that. So set pixel v, so set pixel with a vector pixel, and the second thing is the color. So for now, let's just make them white. All right, so all our generator does is create 100 white pixels just to convince ourselves that it's actually working. And there we go, 100 random white pixels. And of course you can turn on symmetry and you can actually see the symmetry. So the template code is actually doing that for you. You don't have to do anything extra to get the symmetry to work for you. So I'm going to do one other thing too. The order in which things appear in this list here is based on the order which they appear underneath this gener node. So just temporarily, I'm going to move this up to the top so that every time we run this, I don't have to select that. It's just the one that pops up by default. Okay, so what I want to do is I want to implement this wandering pixel idea. And so let's use this as the random starting point, and then what I want to do is I'm going to move in a random direction until the pixel moves outside of the actual image area. So I'm going to need a rect which tells me the size of the image. This is going to go from 0, 0 to, I think there's a get size. Yes. Okay, so while image rect has point pixel, so let's draw the pixel. And for now, again, let's just make it white. That's just easier. Now, I need to move in a random direction. So probably the easiest way to do this, since this is a vector, is just generate a normal. Or, I'm sorry, just generate a normalized vector that will point in any direction. So pixel vector 2. All right, that should do it. Now, I do realize that that's going to, so since the pixels are on a square grid, so that means a diagonal pixel is a little further away than a horizontal pixel, that this could end up, writing the same pixel twice if you go in a diagonal a lot of times. But also it's going to you know, it's going to travel back on itself because we're moving in a totally random direction here. So we'll just keep setting pixels until this thing wanders off of the screen. So let's see what this looks like. And why are they all going in the same direction? Oh, because this needs to be -1. All right, so there we go. So get some interesting shapes here. So what would make this more interesting is if we put multiple wandering pixels on the same image. So let's do like 10 of these. And then instead of just using white, let's use a different color for each pass. So Alright, so I'm just going to use a completely random color and even a random color alpha, which should give us some interesting effects. So we're going to put 10 of these things on the same image, and they're all going to be random colors. No, they're not. I didn't change the... Here. And why is there only one? I have to reset my starting pixel. All right, we need to set the starting pixel at the beginning of each loop. What's it complaining about? Oh. There we go. That's the effect I was looking for. So with very little work, we have a very interesting looking tile generator already. That looks interesting. You know what would be really cool? If we set the background to some solid color. Let's do that. Just reuse this variable. All right, so what I'm about to do here is I'm gonna set the background to a solid color. And that should make it more interesting. Cool. Now, at the moment, it's not doing anything with the palette, so it's just completely ignoring that. So let me show you how you can add using the palette. So see that we get this array here, this colors array that gets passed into the pixels array. If there's no palette selected, so the default situation is none of these colors are selected, and you can turn them on individually, or you can turn on the entire palette on and off just by clicking the button twice. I couldn't figure out a better way to do that, so it's kind of a bit of a kludge, but it works. So when you first pick a palette, it selects all the colors. If you choose the same palette again, it just toggles them on and off. So when there are no colors selected in the palette, the array that generate pixels receives is just an empty array. when there is a palette selected, the array that it receives is all of these colors in order, so in the same order. So in other words, color 0 in the array will be this one, color 1 will be this one, and so on and so forth. So we can, so let's do this. So instead of just picking a random color, let's find out if there's something in the palette, then let's use those colors instead. So if colors.size is greater than 0, just pick one at random to be the background. So to pick one at random from the array, I'm just generating a random integer and then taking the mod of that by the number of colors that are actually in the array. So that'll get us a random number that's in the range of the size of the palette. Otherwise, we'll just use a random one. So it's going to pick a color from the palette, and then let's do the same thing down here. All right, so now in both cases, instead of picking a random color, if there is a palette, it will choose a random color from the palette. So let's go see what happens. So again, still random here. So now let's turn this palette on, and all the colors should come from the palette. And be more interesting if we choose, like, well, here we can actually convince ourselves it's working, because now we can see that it's actually choosing colors from the palette. And the terrain palette. You know, this looks kind of like camouflage. This is kind of interesting. You know what would be cool? So, all right, so let me show you how to add a palette. There's a couple of things you can do. So one thing, so if you go to this palettes code here, all of the palettes are just exported arrays of colors. So one thing that you could do, and the reason they're exported is so that you can edit them in the inspector as well as just putting in the code. So let's say you have some favorite colors. I'm just going to copy this, make it easier. My favorite colors. All right, so I just created a new array of colors called my favorite colors. So I go to the inspector for palettes. I can find this one and I can actually edit it. Let's just add 3 colors here. And I don't know, we'll just pick some at random here. Maybe a blue one. Maybe a purple one. I don't know. All right, so that palette will now show up in here. So there we go, my favorite colors. And if we generate, it should use those colors. So it's fairly easy to add new palettes. There's currently no way to save the palettes, and part of the reason is because I didn't really intend this to be an end user tool, so I didn't plan for people who were not using Godot as a coding platform to be using this. If it is going to be used that way, there are a lot of other things that need to be done, like some things that need to be checked and boundaries and so on and so forth. So if you want to create a new palette, just put it into the palettes array. So this palette looks like, I'm sorry, this generator looks like camouflage. So let's go multicam palette colors. So we can find the colors for multicam. All right, so let's use these colors. Let's make a palette with these colors. How many are there? 1, 2, 3, 4, 5. Oh, I should have put the quotes in there. Oh well, we'll do that. All right, let's go grab these. Up. All right, let's see what that looks like. Kind of cool. It needs more wandering pixel layers. Where was that at? Actually, this is a good time to introduce how to. Okay, so we had it set to 10. So let's change this to for I in passes. All right, so let's just create a variable called passes here. So this is a good time to introduce how to add more properties to your list. So you just create a variable and give it some default value. And then to tell the inspector about it. So I did have a version of this that would go through the code and read all of the exported properties and put those in the inspector, but there was some functionality that I couldn't figure out how to get, like how to make these option arrays and things, and so ultimately I decided to just have a dictionary that would tell the inspector these are the variables that you need to be concerned about. So you can see that symmetry is the only one that's in the list, and as noted earlier, my code implements that already. So let's add passes. So what we do is we give it the name of the variable, and then this is a dictionary entry, and so the comments up here tell you what your options are. So this is going to be an integer, and the minimum number of passes should be 1, and let's say the maximum number of passes is like 1,000. All right, so once we've done that, this option called passes will show up in the inspector, and then we can play with it. So notice it's now set to 10 passes, so let's change it to 100 and do it again. And so now it's really filled in. And you can see it takes more time. So let's change back to our multicam palette and see what this looks like. That's kind of cool. All right, so there you have it. There's Tiley Jenner. I will post a link to the GitHub repository for this in the comments for the video, and I'll probably post this in the Godot forum on Reddit and other places, so hopefully you can find the code if you want and you can play with it. I released it under the MIT license, so anybody's free to do with this whatever you want. I hope that you find it useful or fun, and let me know what you think. Thanks.